The transacylation of valinol with ethyl formate affords the corresponding formamide, with high chemoselectivity for acylation of the primary amine in the presence of the primary alcohol. In this tutorial, this example of the nucleophilic acyl substitution mechanism will be described in detail. Notice that no acidic or basic catalysts are present. The first step is nucleophilic addition of the amine to the ester carbonyl. This gives a tetrahedral intermediate, which is positively charged on nitrogen and negatively charged on oxygen. The tetrahedral intermediate is less stable than the neutral amine and ester reactants, so the equilibrium will favor reactants. It's tempting to proceed from the tetrahedral intermediate to directly form the carbonyl by elimination of ethoxide. However, notice that the cationic nitrogen cannot participate in resonance stabilization of the carbonyl. Thus, another pathway is likely. The second step is probably proton transfer from the ammonium cation of the tetrahedral intermediate to another molecule of the amine. The equilibrium constant for this transformation is approximately 1 due to the similar pKa's of the ammonium cations on both the reactant and the product side of this equation. In the third step, elimination of ethoxide now gives the formamide. Ethoxide then accepts a proton from the ammonium cation, which now regenerates the amine for acylation itself, and this leads to stoichiometric formation of ethanol as the byproduct. In summary, the transacylation reaction occurs in 4 steps. The first step is nucleophilic addition of the nitrogen of compound 1 to the carbonyl of ethyl formate, compound 2, to provide a tetrahedral intermediate, compound 3. In the second step, proton transfer occurs from structure 3 to amine 1. In the third step, the resulting anionic tetrahedral intermediate then eliminates ethoxide to provide the formamide product, compound 4. And in the fourth and final step, proton transfer from the ammonium compound to ethoxide gives the free base amine, compound 1, and ethanol as a stoichiometric byproduct. As you read through the remaining examples in this chapter, pay attention to the proton transfer steps in addition to the nucleophilic addition and elimination steps of the nucleophilic acyl substitution mechanism.